Hello guys, welcome to this recitation on object-oriented programming in Python. In this recitation, we'll cover some core concepts of OOP, such as class and object, the attribute and method that define the class behavior. We'll cover the notion of encapsulation for data protection, and also the abstract way of writing Python code with class. And we'll look into inheritance and polymorphism. So let's get started. Python itself is an object-oriented programming language which offers different methods for organizing and programming for efficient work. In Python, to do object-oriented programming, we take advantage of class, which basically define the blueprint or the template that we use to represent object and data from the real world. Once we create a class, we can instantiate many objects from the class, which is the real representation of the class. So how do we create a class in Python? To define a class in Python, we use the keyword class, followed by the class name here, which is CMU student. Basically, we'll start the class name by a capital letter, as we can see here. And inside the class, we'll need to define the constructor that help to create a class, to create an object later, sorry. And the constructor here in Python is init. So it's a bit like what we have in some of other programming languages, such as Java or C++. But the way we define the constructor here is different. So the init method, like any other method in the class, will have the self parameter, which is basically an element that we use to identify the object itself, followed by some key parameters that we need to provide for our constructor when we want to create an object. Here, for instance, we create a CMU student class with some attribute, the name, the major, and the student ID. After defining our class, we can create some object from it. Here we create two objects, Alice and Daniel, who are two students at CMU, and we also define the major and the ID. Now let's try to print out the two new students that we've created. So after trying to print out the student that we've created, we can see that Python shows us that they are CMU student object. And we also have the information about their location in memory, which is here. Apart from that, we can try to access some information about the student that we created. To do that, we'll need to use the attribute. And how do we access the attribute from a given object? We basically use the dot operator in Python, followed by the attribute name. So here we can print here the student name or the major, and also the ID. These are the attribute that we define for our student that we gave when we were creating the object. So you can see the student Alice name. We also have the major, which is computer science, and the Android LND. These are some way of accessing the object information from the class, but we can go beyond and define some behaviors for the class that allows the object to have a good and real manipulation. To do that, we'll use the method. So the method are some function that we embed into the class that we'll define inside, and we help the student, we help the programmer, sorry, to manipulate the object and see the behavior. So if, for instance, we would like the student to introduce himself, we can define the method we'll call here introduce, and then this can return a particular element. This can be either a string or a number, depending on what we are doing. So this can be any type of object or maybe variable that we return. But in the particular case of what we are doing here, we create an introduce method, and it returns a string representation that present the user. We can also define other methods, but we have another method here, which is the rep method associated with all the class we created, but by default is not overridden. So if we want to print details or we want to use the object and print it straight to get more detailed information, we can use the rep method from Python and override to return a string representation of our class. So this will give for any object a string representation. So let's now define it and try to use it. After defining this representation for the class and some method, we'll try to use it by creating new student. Here we created again the student Alice, and we add the student score. Now we try to introduce the student by using the print method, which will basically print out the string returned by the introduce method. So we can see my name is Alice and I study computer science. My Android ID is Alendi. Now let's try to see when we try to print the student now, what happened after defining the wrap method. After defining the wrap method, which return a string representation of the object, you will see that the print student is no longer returning the type of object and the location in memory, but instead is returning the string representation that we created in the wrap method. So for any class that you will create later, if you want to use a string representation instead of getting the object type and the reference in memory, you will just need to override the wrap method, and then you return what you would like to use for your program. We can go and forward and try to use some of the other methods that we've defined in the class. For instance, the get score, which basically return the student score multiplied by 10. So if we try to use it here, you will see that the score that we've defined before was 5. And then this, well, for the student here was 7.2. But when we try to get the score for this new student, we now have 72. These are some of the way we want our class to be used and manipulated. But if we like to have some attributes that are private to our class, we don't want it to be accessible out of the class, we can use a way that we usually use in some of other programming languages such as C++ or Java to protect our data. But in Python, we do it by starting the variable name, our attribute name, by 2 underscore. In some other programming languages such as Java or C++, you can use the keyword private. But here we start with a double underscore and then we give the attribute name. Here we are doing the same thing for score. And now we'll try to create a new object from the new defined class. So we create the student Alice again, And we try to get the student info with the method info that we've defined. And you can see that all the information appears normally with the score. Now let's try to access some of the attributes that the student has. So we try to print the student name, it's given Alice, but now we try to access the score, the student score. When we do that, Python return an attribute error, which is saying that this object, the semi-student object that we've created, does not have any attribute named underscore score. So how do we overcome that kind of issues with the attribute that are not accessible out of the class? We then use the particular way of we'll define new methods, the setters and getters. So the setters will be responsible for allowing user to modify the variable, the attribute score, when the getter will allow us to get the values the way we want to return the values from the class. So here we define the set score. The setter start with the set, and the getter will start with get. The setter does not return anything because the only thing it's doing is just modifying the object's attributes value. And the getter will now return something of type of the attribute that we have. So here we are returning the final score, which is the score that the student has multiplied by 10. Now we'll create a new student again, Alice, with the score. And by default, when we define our class and we create a new student, we say that the score by default is none. So there is no score assigned to the student. Then we try to set a new score and we'll print it. So when we do that, as I've said, the set method is not returning anything. That's why when we print the result from the set score, it's given none. Now let's try to get the student score and see the output. So the output now is 55 because we set the score of the student to 5.5. This modified the value that we originally had, and then we have 55 for the student for the final score. So thank you, and this takes us to the end for this part of the recitation. We'll continue in the next video with some core notion like abstraction, inheritance, and polymorphism. See you. Hello guys, welcome to this second part of the recitation on object-oriented programming in Python. We previously covered the notion of how to create a class and object and access the attribute from the object. We also had the opportunity to cover how we create a method in class and also how to use the notion of encapsulation to protect some of the attributes that we're using in the class. Now we'll cover the notion of abstraction, inheritance, and polymorphism. The abstraction in object-oriented programming is a way that we use to simplify the complex system that we are modeling, so in such a way that we define some property and behavior relevant to the program while hiding the unnecessary details. For instance, if you suppose that our CMU student here has a list of grades during the semester, the only thing that we want the user to know is that we can add the student grade somewhere. We'll keep it maybe in the list, and then later we'll need to return this final grade that the student has in the semester. So here we add a new attribute to our CMU student class, which is the grade, basically a list of grade that we want to hold. And we'll add other methods like add grade, which will push maybe append a grade to the list of a grade that the student has while hiding this behavior to the user. The only thing that the user will know outside of the class is that we have the possibility to add the student grade, but how this is handled uh, in the program is not really explained to the user. So we have two methods, the add grade, which will append the grade to the grade list, and then we can calculate the GPA by using the list of grade that we already stored. Then here, let's create a new student and define some grade for the student. And we'll try to compute the final grade that the student has. So by doing that, we create a student Alice with the major in computer science, and her Andrew ID, sorry, is Alendi. Then we define three different grades and compute the final GPA for the student, and we can show it here. So this is a way of trying to manipulate some of the information from the class without showing all the process that we use to do that. Another thing that we can do in Python, like in the real world, is the inheritance. In the real world, when we take a family, we have the father and we have the children. So here in OOP, inheritance will also follow kind of the same thing, but what we define like inheritance here will allow us to have some subclasses, and this subclass or maybe child of a given class will be called the child class, and the class from which we inherit is the superclass. So the superclass is the parent class here. For instance, we already had the CMU student class, right? Now let's try to create a graduate student. So a graduate student is also a CMU student. So if we define it that way, to create the inherited class, we start by a keyword class as we've defined, we said before, because when we want to create a class, we use the keyword class followed by the class name. We do the same thing. Then we put in, we will give to this newly created class, the CMU student class, to say that it's inheriting from that class. Then we'll define its constructor, but there we'll also need to initialize the variable if we want the variable for the super class. Because we are inheriting, we also have access to the attribute from the superclass. So we'll need to initialize these attributes. To do that, we'll make call to the superclass constructor through the specific element super here, then dot the init, which is the constructor from the superclass, and then we give all the attribute information necessary for that. Then in our inherited class, we can define our custom attributes. Here, for instance, we define the research area for the graduate student. And we can also define a particular way of displaying maybe the student's information. So we just make call to the superclass method to display the information. And then we can also make custom arrangement in our class for it to be a little bit different from the parent class. After doing that, we have our new inherited class. Now let's try to create a new CMU student. Here, basically a graduate student. So we create a graduate student, Bob, in electrical engineering with the research area signal processing. Then we also add the grade for the student, and we try to display the student information. And you will see that when we try to do the display for the student information, it may call to the super class display method to display the student and also print out the research area for the student, which is signal processing. And we also have the final GPA for the student because the inherited class has access to the attribute and also the method from the superclass. Besides that, there are a couple of things that we can also do in object-oriented programming in Python. And here, particularly, if we would like to have 3, 4, or 6 different inherited class, but we want them to custom the way they use some of the methods from the superclass, we can do that through the notion of polymorphism, which is giving basically the ability of subclass to change a method which already exists in the parent class to meet its own needs. That's what I was saying. If, for instance, the student from CMU has different ways of presenting himself, and a student from maybe MIT or Harvard has different way of presenting themselves, they will like to have this method in customized in such a way that this fits into each of the schools. So we'll try to do the same thing here as well. And then first we need to define the superclass, here the student, and then a CMU student will be a normal student. So that's what we have here. The student from CMU will like to say what is he's studying at CMU, while the student from MIT will also like to say it another way. For that, we define the study method in the student, and each of the inherited class will redefine the study method their own way. That's what we've done here for CMU and MIT. And now we instantiate a list of students. We have one student from CMU and another from MIT. And we try to print to show what they're studying. And you'll see that this is a list of students. But when we try to make call to the study method, for each particular class of object that we created, they use their own method to present themselves. The first is CMU student. So we see studying computer science at CMU. And the second one is the student from MIT saying studying engineering at MIT. So thank you guys for watching this recitation. We are at the end of this first part. The next one will cover the main notion of how we use object-oriented programming in deep learning. So thank you and see you in the next.